Welcome back, Chemistry 30. This is the last video of the 19.3 booklet. So in the last one I left you with the strong acid and base questions, assuming of course 100% dissociation, and then from that figuring out pH. So the one I left you with here, this is one of them, nitric acid, so we assume it's a strong acid. At equilibrium, whatever I had as the acid, it dissociates into hydrogen ions. So here 0.28 molar, so that is simply the hydrogen ion concentration. So if I take the negative log of that, I get 0.55. If it's a strong base dissociation, similarly it dissociates into ions 100%. So here I don't have hydrogen ions, but I have hydroxide ions. So when I have hydroxide ions, I could do one of two things. I could either use this equation to figure out how much hydrogen ions I have, or I could figure out the POH, then from there figure out the pH by subtracting it from 14. Whichever way you choose to do it. I chose to use this equation here. H times OH gives 1.0 times 10 to the minus 14. So dividing by that, and I get the hydrogen ion concentration to be 2.27 times 10 to the minus 14. Then when I'm taking the negative log of that, I got 13.6. Okay, the last part deals with weak acids and bases. So for this, we have partial dissociation. And for this, we're just simply figuring, okay, it's a weak acid. What is the Ka value for it when given the pH? So I have the pH. That'll help us figure out the hydrogen ion concentration at equilibrium. So if I have pH, I can figure out what H plus is. So 10 to the negative 2.3, 5.01 times 10 to the 3. So with that, I know what the hydrogen ion concentration is at equilibrium. The acid starts off with 8.6 times 10 to the minus 3 molar. So to figure out how much is actually used up, since it is a weak acid, I started off with 0, ended up at 5.01, so I must have added 5.01. Now this, I just assumed it was the first dissociation here because it says here the first ionization. And it's a 1-to-1 ratio, which is nice. In the practice questions you'll have 2-to-1 ratios, etc., so you'll have to be aware of that. So if I added 5.01, I must have used up 5.01, because for every one of these that dissociates, I get one hydrogen and one H2PO4 minus. So 8.6 times 10 to the minus 3 minus that 5.01 times 10 to the minus 3, 3.59. So I know the equilibrium concentrations of H2PO4 and H3PO4, so I can figure out the Ka, the acid constant, products over reactants. As you can see here, I know the product values, the reactant values, and then we get that, 7.0 times 10 to the minus 3. Okay, so maybe pause the video and I'll get you to try part B. Very similar, set it up the same way. I'll give you the equation here, chloroacetic acid, and we'll just assume it breaks it down into one hydrogen and C3H2ClO2. Okay, if you had a chance to do that, of course, we know what the pH is. So if we know what the pH is, we can figure out the hydrogen ion concentration at equilibrium. So there we have it right there. So 10 to the negative 1.92. So I get 1.20 times 10 to the minus 2. So that is what my hydrogen ion is at equilibrium. So if I start off with 0 and added 1.2, I must have subtracted 1.2 from this side. So 0.112, subtract 1.20 times 10 to the minus 2, I get 0.1. Okay, and then setting up the acid constant equation, products over reactants, multiplying products over reactants, and I get 1.44 times 10 to the minus 3. Okay, that's it. So we just have the vocab now. So the ion product constant for water, or Kw is what I referred to it as, the value of the equilibrium expression when water dissociates. So H times OH gives 1.0 times 10 to the minus 14. pH stands for potency of hydrogen ions. determines how acidic or basic an aqueous solution is. So pH equals negative log of H, the concentration of hydrogen ions. POH is the potency of hydroxide ions. So determines how acidic or basic a solution is as well, except looking at the opposite scale. Okay? And a summary of all of the formulae here. You may want to copy out this on the bottom. So we have the ion product here, the KW equation, pH and POH, the relationship between pH and POH, and lastly, if kind of like a Jeopardy question, inverse operation. If we know what pH is, we can figure out hydrogen ion concentration. If we know POH, we can figure out hydroxide ion concentration. And what you may also copy out, if you haven't done so already, is the relationship between all of these. So if you know pH and you're asked to find hydroxide, you can see there's two different paths you can take there. Okay, so there you have it. That's the end of 19.3.